Autonomous vehicles must comply with traffic rules. However, most existing motion planners don't consider all relevant traffic rules. Once traffic rule violations of trajectories are detected, there is often not enough time to replan the entire trajectory. To solve this problem, we propose a novel approach to generate rule-compliant trajectories based on a trajectory repairing framework. As shown in this figure, the initial planned trajectory for the eagle vehicle violates the traffic rule since it doesn't yield to the vehicle entering the main carriageway from the access ramp. In our approach, only part of the initial trajectory is repaired to avoid the incompliance. By making use of a lazy satisfiability modulo theory's paradigm, we can reason whether and how the trajectory can be repaired, given traffic rule formulas in metric tempo logic. Let's consider the German interstate traffic rules. With the general rule RG1, the eagle vehicle following vehicles within the same lane must maintain a safe distance to ensure collision freedom for all of them, even if one or several vehicles suddenly stop. In the demonstrated rural scenario, the initial planned trajectory for the eagle vehicle violates the safe distance rule. Using our approach, the eagle vehicle executes a braking maneuver to avoid the violation. With rule RG2, the eagle vehicle is not allowed to brake abruptly without a reason. After a violation is detected, the initial trajectory is modified by our approach with a more reasonable acceleration profile. Rule RG3 states that the eagle vehicle must adhere to the speed limit. We show an urban scenario where the eagle vehicle exceeds the land speed limit. With trajectory repairing, a comfortable and rule-compliant trajectory is obtained after the initial trajectory branches off. Furthermore, we compare our approach to trajectory replanning using a sampling-based planner with the same traffic rule monitor used in our approach. The result shows that replanning the entire trajectory is more computationally expensive than trajectory repair. We also evaluate our approach with a high dataset on over 1,000 rule-violating trajectories. The result shows over 95% of trajectories can be repaired to comply with traffic rules using our framework.